Welcome back to the Stone Den. Mossback the wood rat has carved out quite a living space down here in the rocks. But burrows in nature don't look like perfect, simple shipping containers. Mossback's home is an irregular space, branching out into different connected chambers and corridors. If we want to know the total volume of his entire den, how much space he has to store food and sleep, we run into a problem. We can't measure a multi-part space like this with a single measurement. To understand the reality of this den, we have to look at it differently. We can find the total volume by splitting the space into simple boxes, measuring each part, and then adding them together. Watch what happens when we pull the burrow apart. The continuous den separates into distinct rectangular chambers. Notice the clean breaks between them. These shapes do not overlap. They don't share any of the same interior space. Because the parts are completely separate, we don't have to worry about accidentally counting the same space twice. Once the space is split, finding the volume becomes an addition problem. Look at this first chamber. We can establish its physical floor plan by packing it with a layer of unit cubes, creating a grid that is 3 units across and 4 units deep. To calculate the cubes in this base layer, we multiply the 3 rows by the 4 columns, giving us 12 unit cubes. Now, a second identical layer of 12 cubes fits on top to reach the ceiling. With a 12-cube base stacked 2 layers high, we multiply 12 by 2. The volume of this first chamber is 24 cubic units. Finding volume is essentially counting every single spatial unit packed inside a shape, with no gaps left empty. For the second chamber, we can use a method that doesn't require packing it with individual cubes to find the capacity. This room is a box 5 units long, 3 units wide, and 4 units tall. To measure it, we substitute these dimensions into the standard volume formula, length times width times height. We multiply 5, 3, and 4. 5 times 3 is 15, and 15 times 4 gives us 60 cubic units. The formula acts as a shortcut. It allows us to find the total volume directly from the outside edge dimensions. Let's check Mossback's final room, the storeroom, to see another way to reach the same goal. In this room, the entire floor has a base area of 18, and the room rises to a height of 5 units. Applying the base area formula, we multiply the base of 18 by the height of 5. 18 multiplied by 5 equals 90 cubic units. Knowing a shape's total floor area lets you bypass calculating the length and width separately. It proves there are multiple ways to find the volume of a single part. We now have the volumes for the 3 pieces of Mossback's home, 24, 60, and 90. When we put the burrow back together, the separated chambers reconnect into the single shape of the den. Because these chambers do not overlap, their volumes combine. 24 plus 60 plus 90 equals a total volume of 174 cubic units. A home made of these box-shaped chambers can be measured by isolating each rectangular part, finding its volume, and adding the sums together. Mossback moves through the passage, at home in his unified burrow. The wise math Sheba rises, curls its tail, and trots off across the warm rocks. Split into boxes, find each, then add. A multi-part home is manageable once it's broken down into pieces. I'll see you at the next bend.